The Polaris graphical user interface is based on Antares. Antares is an open-source graphical library which was developed within the Polaris framework. Antares renders a high-performance 3D graphics or 2D plot based on configuration information and visual data which is provided by the user. It provides general capabilities which are not specific to transportation and may be used for any agent-based application created within the framework. Developers may use Antares to create new graphical effects or provide increased interactivity with an underlying simulation. The Polaris GUI presents many useful features for modelers. The running simulation may be paused at any time to survey the prevailing conditions. Individual objects may be selected and inspected. The GUI allows the modeler to introduce new information or make changes to the model on the fly. The modeler may overlay an array of dynamic 3D plots which highlight critical measures of effectiveness. Finally, the modeler may even record videos to present results or keep a visual record. In this video segment, we will look at how the Polaris graphical user interface is laid out, examine the scope of the Chicago metropolitan area model, get an under-the-hood view of individual agents. The graphical user interface you see here was developed using the Antares 3D graphics library. These are the major parts of the Polaris GUI: the layer configuration panel, the time control panel, the 2D plotting panel, and the attribute display panel. The plotting panel may be hidden to enlarge the working space. The canvas area allows navigation in 3 dimensions. You can rotate, zoom, and pan. The Polaris Integrated Transportation Model has the capability to simulate and visualize large regions and millions of agents. The region displayed here is the Chicago metropolitan area. It covers roughly 10,000 square miles and has a population of approximately 9 million people. The agents in this simulation make many of the same decisions a real person makes throughout the day. They decide what they would like to do, where to do it, what time to leave, and how to get there. They drive on the road with other agents and will even change their plans throughout the day if circumstances change. The visual interface is fully integrated with the model. The vehicle movements you observe are the result of those decision-making behaviors conducted by thousands of individual agents. These behaviors are executed in lockstep with the visualization. As you can see, even for large regions, Polaris runs much faster than real time. This area is the Chicago Central Business District. The city of Chicago has a population of 2.7 million. Watch as the vehicles make individualized decisions about what to do and where to move. As we move out of the downtown area, the other vehicles can also be seen making individualized decisions and moving throughout their day. This community is called Rockford. It is about 80 miles outside of Chicago and it has a population of over 150,000. The agents here are governed by the same behaviors as those in the downtown. Individual layers may be selected or turned on and off as in a GIS software. We can quickly browse vehicles or select one individually. The selection feature allows you to get an under-the-hood perspective about what each traveler is thinking every second of the day. Current information can be made available for many objects in the simulation, including links. The attribute panel shows characteristics such as number of lanes, current density, or facility type. Individual links may also be browsed rapidly. This concludes the introduction to the Polaris Integrated Transportation Model and Software Framework.